Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. I want to present our research, and the title is the effect of polyethylene glycol and cellulose acetate loading on the characteristic of polyether sulfone membranes. Before I start our presentation, I want to introduce our team to you. My name is Frastia, and our team is Yunita Fahni, Intan Triwahyuni, Wika Atra Auriani, Desiriana Saputri, Damayanti, and Andri Sanjaya. We are from Department of Chemical Engineering, Institut Teknologi Sumatera. In this presentation, we had an outline. The first introduction, the second is methodology, the third is result and discussion, the fourth is conclusion. The biggest challenge is using membranes and is the following because increase the following factor can make a side effect for membrane performance. And PES is the hydrophobic properties, and the hydrophobic surface leads to the biofouling effect on the membranes, which has consistently been regarded as a significant limitation for the application of PAS membrane in technology. To the best of our knowledge, there is no research into the utilization of combination of PAG and CA as additive for PAS membranes. Therefore, the work aims to study the effect of PAG and CA loading on the characteristic of PAS membranes. It was hypothesis that the presence of PAG and CA will improve the membrane characterization. Methodology, material. The first we had a polyether sulfone and methylpyrrolidone, cellulose acetate, polyethylene glycol, ethanol, and aqueous. Membrane preparation and characterization. For membrane preparation, we had a 5-step. The first is preparation of casting solution. The second is membrane modification with PAG and CA. The third is removal air bubble from polymer solution. The fourth is membrane casting, and the last is soaking in the coagulation bath. On the characterization, we had a swelling degree test, tensile strength, FTIR, contact angle, and SEM. Result discussion, the first effect of addition of CA and PAG on tensile strength of PAS membranes. We have C to figure 1. In figure 1, addition of PAG can have a lowest tensile strength because PAG is a pore-forming agent. Pores of membrane structure make fragility of the membranes, and the highest tensile strength is addition of CA because addition of CA experience is and increase the viscosity of the membrane and result in a dense membrane structure. We can see in the figure A and B before and after addition of CA. And modification of PAS membrane with the addition of CA and PAG is an anti-synergetic combination that result in a decrease in the mechanical strength of the membranes. Effect of addition of CA and PAG additive on membrane swelling degree. We can see in figure 2, the highest swelling degree and addition of PAG and CA because PAG and CA, both of them is hydrophilic properties, and the addition of these two additives have a synergetic effect in increasing the swelling degree. Effect of CA and PAG additive on a membrane contact angle, we can see in figure 3. The lower contact angle is the addition of PAG and CA because both of them is the hydrophilic properties, and CA more hydrophilic than PAG. Based on the Wanjuan Chen 2009, CA membrane has a contact angle of 54 degrees. And this proves that the mixing between CA and PAG additive work well together and significantly increase the hydrophilicity of the membranes. Chemical functional group analysis of membrane surface. We can see in figure 4 and table 1. We can see in the addition of PAG, we had a wave number and methylene function. We can see in PAG structure, and we had a cluster function of C double bond O or carboxyl acid. We can see in the CA structure. Membrane morphological analysis for we have a figure A and C as a membranes control, and membrane modified. Before modified, pore-size membranes start from 0.06 until 0.2 μm. And after modified, pore size is range from 0.3 until 0.6 μm. Modification of PAS membrane with PEG and CA additives show an increase in the pore size, increasing membrane hydrophilicity, and the type of membranes are microfiltration membranes. And the last effect of addition of ethanol, variation in coagulation bath on PAS membranes. We can see in the ethanol 60% is an optimum filling degree, because in this phenomenon, and ethanol 60% producing the large pore size and high membrane hydrophilicity, and resulting in a good water absorption on the membranes. The number of membrane pores decrease with the increase the ethanol content in the coagulation bath liquid mixture. And this is due to this suppression of the coagulation phase inversion with the increasing ethanol content as the mixture of water and ethanol diffuse into the casting solution at a slower rate than when there is 100% water in the solution. Based on our research, PEG influenced the properties on the PAS membrane by enlarging the pore size and thus improve the membrane hydrophilicity. CA enhanced the hydrophilicity of the membranes by creating a sponge-like layer and reducing pore size, concurrently increasing tensile strength. And the last, the optimal non-solvent concentration for modification in coagulation bath determined to be 60%. As a yield, a greater swelling degrees than an aqueous coagulation bath, leading to enhanced hydrophilicity. The author thanked the support of APBN, LPPM, RKAT Institut Teknologi Sumatera for funding this research. And that is our reference we can see in the slide. And thank you for your attention. We hope that research can have a benefit for you. Thank